Hello. It's time for our linked list manager to come forth and manage all this pooey stuff right here that we did in our last video. Because this is kind of nutty. Because I mean, seriously, if I want 4 objects now or 5 objects, how long is this line going to get? Dot next, dot next. Yeah, I'm done. Catch out. We're gonna fix that. Because I mean, seriously, if we have a list of a million items, that dot next is going to get very, very tiring. Well, fortunately, of course, we've got loops that'll do that for us in some kind of management class, and that is what I call the linked list manager. It's going to manage our nodes. Our node class, remember, we built. And it's very simplistic. It holds some data that is any kind of data that is available or can be created or defined within Java. It can hold because it's at the lowest level object. And so we can box it up in the node and unbox it at will as much as we want. And actually that's going to be our goal is let's not do this with and that's another thing that drove me nuts when I was learning is a lot of the linked lists that I was given was taught to me using simple data types. Because always when I tried to implement user-defined data types in my own objects, things would break and I just, was having an issue with, going between the two because there is a difference somewhere. There always is. So we'll see how well that goes today. We're gonna create our own object eventually. We're gonna start with simple data types though. Okay, yeah, whatever. But then we're gonna test it. We're gonna do a run because that's the beauty of Java is actually taking out of our realm with this whole idea of objects. What is an object? Everything in Java is an object, and so therefore we can assign line 18 to any data type available or even thought of. So we're actually writing code that's for the future as well. It's crazy. Yeah, that's why this technology took off. And just the higher level languages like C# and Java, JavaScript sort of, but those guys with memory management really are useful. So one thing that we do not have to worry about is managing our nodes, our memory, because when we stop using it, the garbage collector will automatically detect it and delete it for us. So we can just kind of at will just add stuff and ignore stuff as much as we wish within our linked list infrastructure. So let's go ahead and begin. What we're going to do is I'm going to go ahead and create a new Java class. And this class is going to be called L Manager. And now let's call it List Manager. List Manager's fine. All right, this is going to be our beginning of our work. So this is an object that people will instantiate that will give them access to be able to create nodes with data inside of it. And that means that, just like we kind of learned over here, we have to have always our first link, our head, the head of our list. We can't lose the head. And it's something that we call root. And so the linked list manager is going to have that root. And it's going to be a pointer that points to or references initially nothing. We're going to assign it nothing because it's going to start out as whatever. Let's get into it. I lost what I was talking about there for a second. That happens. The node that we're going to create for root We're just going to call it root. Actually, more traditionally, it's not root. It's actually head. Don't lose your head. That's the old joke. And this actually has to be assigned to null when we first instantiate it. And so this is kind of like that root variable. And so what I'm going to do now is I'm going to do a constructor that's going to assign head to null. And I think that's the way to do it in Java. I always forget. We'll find out later. And so this is the base state of our linked list manager. And so what does that mean then? Okay, well what that means is we got a reference to a node. And what does that look like? Well, we call it head. So the name for it is head. Let me get this guy right here. Okay. So our head, oh my goodness. I'm starting out really bad already. Okay, head, the head. That is a pointer, a reference. When we set it to null, this is the head, our head variable. When we set it to null, we're essentially putting 0 in the storage of the head. And let's say that that reference, even though we don't even really care about it, but that head variable lives and breathes at location 1000 in RAM. You know, even though, you know, we're not going to do much with it. Let's just put it in here. This is what it looks like. So it essentially points nowhere. That's what we've just created with our manager. And that's what this line of code does. So that's our starting point. Now we need to populate the list. And by populating it, I mean the careful instantiation of node objects that are linked together in some manner using references and self-referential references. Yeah. Yeah. A little on the nutty side. All right. Let's get in here, and here's what we're going to do. We're going to have a very simple function. We're going to call it add front. This function is going to take an object, any object, that we send it, and we have to box it up as an object. I'm just trying to think of a good name. I'm just going to call it N for new object, because I don't want to use the new keyword. So that is the object that we're going to begin to work with and what our node is going to hold. And that means that we need to have a base case to know when there's nothing on the list. And currently, this is what we have. We have head that points nowhere. And that's how we know that there's nothing on the list, is because head is equal to null. So I'm going to add here, if head equals to null, then that's going to be a very special case. That means we've just started our list. And that means then that I'm going to assign head equal to the object that we're passing in. Oh, excuse me. Head set next. Dot next is equal to n, but we've got to instantiate head dot next because head's next doesn't contain, oh no, we got to instantiate head. Oh my God, what am I thinking? Head equals new. Yeah, we got to instantiate head because it's a pointer, and we got to create our first node. So I'm going to say head is equal to new node, and then head's data equals n. Okay, now what does that do? What that does is it creates a new node in RAM. That's what this line does. And so that new node gets created. It has a next inside of it that points to 0. Because remember, every node has a next that points to 0 currently. And it has an address. Let's say that it's at location 2000. So as soon as we say head is equal to new node, the operating, the program asks for memory RAM from the operating system. It returns the address to the first byte inside of that, or where that actual object exists. So now head, instead of pointing to 0, it points to address 2000. And so these are now linked. And that's what the head equals does, is it's only assigning where the reference points. It's not actually, when we're referring to head, it needs to be thought of as a pointer. It's not the node itself. It just points to the node. And the node, inside the node, is the data and a pointer to next. And in this case, when we create a new node, we already assign next equal to 0. And next is just another pointer like head is. And it's going to point to another item. So that takes care of the first bit, and we can run that and test on it. But what if head is now, we add another front? And let's delve into this by actually running this now. It's time to instantiate and do things. Let's do things. All right. Come on. I need to get rid of all this stuff. Okay, we're gonna come back to this guy right here. But what we're gonna have is an instantiation of our linked list manager. Of list manager inside of main. And we're going to instantiate. Then we're going to say manager.add. And here's the beauty of it. We can add anything we want. So we can add a number there. And that's the beauty of this kind of thing, is because we can actually put any data type, and we can have mixed data types. It's freaking beautiful. So I'm going to add front the number 3. Okay, I'm going to set a breakpoint. And we're going to look at that. I got an error somewhere. Okay. Okay, yeah, I messed this up. The base class is actually capital O object. That's what we're gonna be wrapping everything into. So I just kind of messed that up. Is it okay in Node? Yeah, I did it right in Node. I just didn't do it right in the linked list manager. Okay, so capital O, that was the error. I think we can go back now and run this in the debugger and make some magic happen. Okay, here we go. Step into, we're adding 3 to the front. I'm going to step into, and object n is a number that has 3 in it, and the head is null. The head is null. Duh, because we put it in the constructor. So this is the first time we're creating a list. And so now I say, oh, let's create a new node, and then let's set the data of that node to n. Now, you've noticed that I'm kind of, I'm just throwing everything public. So what would actually happen here is you would do a set data equals n, something like that. You wouldn't go directly to the data. You would use get data, set data. In fact, that's what we should actually add here to make this thing a little bit better. I think we might even get some errors if we don't do this right. The constructor is public. Our data should be private. And node next should be private. And then what we should have is we should have some helper functions. Set data, object O, object N, and then we say data equals N. That's the only time that we allow access. So we're going to use set data instead. We're going to now have a set N, a set next, and this one it's going to pass a node. And this is where we say next is equal to n. Then we're going to have a get data and get next. Okay, and this is so that we are doing things properly. It's going to make things a little bit more difficult from the linked list manager, of course. But I kind of like that direction. Doing things the right way. Okay, this is get data, return data. Okay. All right, that fills out our node and all the accessors that we're going to end up using. But these all have to be public. So I'm gonna move my public and my private so that they have different regions. All right, now I'm going to use the public keyword. Oh, I did that wrong. I'm making mistakes all over the place. I think maybe now I got it. Yeah, we're good. All right. That's our accessing, and we're going to use that from LinkedList Manager, and we've probably got some other errors that I got to get into. We'll come back to that. All right, now for the new node, we all of a sudden have no direct access to data. So what I've got to do now is I've got to run the accessor. It's the same thing. All right. Looks like I still got some errors. Oh, this is going to bite me in the butt. Good God. It already bit me. Damn it. The capital O is so hard. It's ridiculous. Silly. All right. All right. Can we get into this now? All right. We create a new node, then we set the data, and that fills this out. So now what we got is we got it properly being used. But what happens if head is not null? Well, this happens. That's where we come in for a second time. We've already added something, and we come in and we add something else. What happens when we add this, when this line gets done running? So this is kind of what we have. We have head pointing to some data. Well, what is the data that we assign that to? That's the value 3. So inside here, we're storing 3. Okay, now we've called this function add front for a reason. And we're going to now add a new node, and we know that we're going to have a new node, and we know that this is add front. So that means that we're going to have the new node up front. So let's just go ahead and create it. Okay, we've got this add front that we've got to deal with. We're putting 4 in there. And our manager is set to only handle when we have 1. And then, but if we already got things on the list, then that means that the list is populated, and we have to treat this a different way with the add front. We know we have the head, but we got to change the linkages because we're going to have a new head. So let's just go ahead and create what I call a current pointer. The current pointer is going to be used. It's just temporarily used, and it's going to be a node, and it's going to have it's a reference. So I'm going to instantiate right off the bat. And one thing that we should have is probably in the constructor a overloaded constructor so that we can pass things in. That would be kind of nice. But what we have is we have this. We have to say current set data. That's the one we just built in Node. And we're going to pass n as the data. Okay, so here's what we've done. We've done this. With these two lines, I have taken something, a pointer that I call current, And it's just like head is. It's the same thing as head. It has its own address that we don't care about, but it's going to store the address to the new node that we're appending or prepending to our list. And that's what the instantiation does. So we got a new node in here. And it's got a next that's just like current. And it's next. I'm just going to call that next here. It starts out randomly as pointing to 0. So it starts out as pointing to 0 first. And current pointer points to address 3000 of our new node that contains the data 4 inside of it. So the goal is to get the currents next pointing, the currents next pointing here, because this is an add front. So its next is going to be the old head. So we want this next to hold the address 2000 just like the head holds. So it can be pointed to that. And then we want no, that just does it. Oh, we want to reassign head to the new head, which is address 3000. So this is what we have first. Well, before I lose my head, let's deal with currents next first. And all I'm going to do is I'm going to say currents next equals, well, what do I want in currents next? I want the address 2000. I want the address 2000 in here. So it points over to this guy. And current now points here, so I can use currents dot next so that I can assign that value. And that's what I'm going to do. So I'm going to say currents dot yeah, this is where we do a set next. Set next to head. Oh, look at that. It auto-filled it in for me. That's the AI. Oh, that's crazy. Okay. So what happens here is when I'm saying set next head, I'm passing head. Head is the reference. So all I'm doing is sending it the address 2000 so that here, next, points to address 2000. And it points there now. Okay, I've made that link. The next link I want to make is where I reset head. Because now head needs to point to the new front of the list, which is the node that has 4 in it. So it needs to have 3000 in it. It needs 3000. Well, where is 3000? 3000 is in current. So if I just say head equals current, the head will now point here the way it should. And this guy's next already points to the next one on the list. And so now this is gone. Now we're linked. But I just need to do head equals current. So I can take this address 3000, put it over here. So head points to the new front at address 3000. Do I do it just like that? I think so. Yeah. That should be it. All right, let's see what's going on here. Oh. All right, so then what happens is that every time I do an add front, that happens. And let's go ahead and kind of look at what it does inside of our debugger. So what we'll do is let's just get a little crazy. We'll add another one and another one, because it's just going to keep repeating those same steps. Add front. It's not going to need anything more than that. And then what we're going to have is we're going to have something that prints the linked list. So we need to put that in the linked list manager. So I need a print function. And for that, we just walk the list like we did and we talked about in our last video. Now I'm going to go direct here to some output that works really good for simple data types, but it's not so perfect. We need to create a current node that's equal to head. So we need to walk the current node, not the head, because current's going to say current is equal to current's next. You see right here? That's what traverses it. All right, now what we're going to do is we're going to let's do this. Okay, current is equal to current.getNext. Well, we'll see what happens here. I'm probably going to have to change a few things. Looks like my print function does not like me. Yeah, I bet you're laughing at me. I didn't even create current. We could do that all in one go. There we go. This we got to change to get data. All right, are we able to print? Let's see. Let's just add, let's go over here and add in here manager.print. Good. Okay. And then run. Okay, there's my output. 2143. 2143. So what it is actually doing is it's the last in, first out. All right. Now, where does this need to, what needs to happen here? What are we going to do next with it? Well, where we're going with it is nowhere. Because you shouldn't really be building your own linked list in Java. They have a linked list available for you to use. That's better and more, you know, it's implemented with much more finesse, I guess. It's more elegant. It's also less error prone, especially cross-platform, to be using these tools that are developed for us. You know, we talked about what a linked list is. Now, the next things that you would do with this linked list creation is you would have functions to add to the rear. You would have functions to add and insert somewhere in between different nodes. You would have functions to remove from the front, to remove from the rear. You would have functions to make it a doubly linked list when you have a previous pointer, and you can say next is previous, so that your linked list works like a circle. And now let me give you a little bit on how that would work. Because there are things that we would add to this, such as now we would have node rear. We would want to keep track of the end of our list as well. And then inside the node class, we can have awareness of not just the next, but we can add another pointer that we assign to its previous node. And what if we got to the end of the list, and the end of the list, it said, okay, Mr. Next, let's assign you to 1,000. Well, guess what? That's all the way over here. and then this links over here, then this links over here, then it goes back over to here and here. This is what they call a doubly linked or circular linked list. Now, if you add in the previous to each of these guys, a previous, and here you had a previous, and that previous linked back over to here, you would have a doubly circular linked list. But the idea is, it's all scribbles aside, let's just get rid of this stuff. Let's look at Java's linked list. Java language linked list class. Because it's built kind of this in the same way, but this is what you would use. And yeah, they've got some interesting, they went templated with it, even though you really don't need it. This is interesting why they do templates with their internal linked list. That is so odd. Maybe because it has to be at such a low level with how they developed it. Okay. You know, my whole discussion about templates might take a rear. No, actually, it's fine. You can box it up, you know, however you wish, and there's multiple. Yeah, you can have multiple implementations. You can build your own linked list with the object inside of it, and it does certainly look like with our library where it's templated, probably because that needs to be at a low level. But of course, you can make your own. But anyways, okay, guys, use the internal linked list. Don't create your own linked list anymore unless you want it to be for fun. Unless you want to use the boxing method instead of templates. All right, take care.